So we're going to be talking about differential equations in the context of Pure Math 3. Now, the thing is, what are differential equations, first of all? We know what algebraic equations are, we know what logarithmic equations are, exponential equations, trigonometric equations. What are differential equations? Differential equations are equations that have a differential term in them. That doesn't help much. This guy. Whenever you see this or any version or d anything basically in an
Mm,
equation, that's differential equation, okay?
okay.
That's essentially the idea of differential equations. So the only method you need to know of how to solve that differential equations is called separation of variables. Separation of variables, which is basically just a little bit of algebra and a little bit of a little bit of algebra and integration. Let's just say that. So let's do a quick example first, okay? So
Okay.
for instance, imagine that you have dy over dx equals 6 times x plus 1 to the power of 2. Okay. This is a differential equation because it's an equation that contains a d term, a differential term. Okay. So
Mm-hmm.
how do we solve this? The idea is we want to separate all the variables, meaning we want to take all of the x things to one side and all of the y things to one side. That's the surface level explanation. But there's one important thing that you have to remember. Whenever, like, whatever movements you do, make sure that your dx and your dy terms are both in the numerator on both sides. Okay.
Okay.
So you cannot have 1 over dx sitting here with all the other x stuff. Okay. You need
Right.
to have dx at the top. Okay, so how do we do it? First things first. Maybe let's multiply both sides by dx. When I do that, I end up with this,
Mm-hmm.
right? That's basically it. Because you see all the y things, well, there's only one, but all the y things are on the left side, all the x things are on the right side, and we're done. So we've
Right.
separated the variables. Easy as that. Now,
Mm-hmm.
just like you can square both sides or square root both sides or divide by 2 on both sides, etc., you can integrate both sides of an equation also. Algebra allows you to do that.
Okay.
Okay. Or algebra's, you know, kind of worse cousin. Calculus allows you to do that.
Okay.
So now you can integrate dy. Technically 1 dy, you can imagine it like that if that helps. What's the
Right.
integral of 1 dy? What do you think?
One dy
Ignore
times
the dy for a second. Imagine what would happen if I integrate 1. What does it become?
one x.
Good. But it's y, right? So we're integrating with respect to y, so it will become y instead.
One. Okay.
So just y basically. Okay.
Right.
Now, and what's the integral of this stuff? Remember, the 6 is just chilling there. He doesn't really take part in the integration.
Okay. So 6 um x plus 1 to the power of 3 over 3. Yeah. And then times, no, just that.
Plus c.
Okay.
Yeah. So now that's basically it. See, you've converted your differential equation into a regular algebraic equation. This is called solving a differential equation. This is
Okay.
the idea of solving a differential equation. So you convert the differential equation into a regular algebraic equation. So essentially the point of this is that I told you that the rate of change of y with respect to x is this much. Can you tell me what the direct relationship between y and x is? That's the idea of solving a differential equation. And the method we used here is called separation of variables. This is the only method you need to know.
Okay.
So you're always going to be like trying to find a way to convert, all the x terms to one side, all the y terms to the other side. Of
Right.
course, things are not as easy as this all the time. Let's try a slightly, I mean, honestly, it's not even a difficult example. Let me show you. So for example, you have dy over dx equals x times y. So how do you suggest I take my, I separate the variables essentially. How do you think I should do that?
You could do dy equals xy times dx.
Yeah, that's always what I do first because then, there's no more denominators to worry about at least. But
Okay.
now this y shouldn't be here, should it?
Yeah. So dy divided by y?
Mhm. Yeah, you divide both sides by y basically.
Yeah.
Okay, and then finally, since you have everything set up, meaning you have the variables separated,
Mm-hmm.
you can go ahead and integrate both sides of this equation.
Right.
Now, what's the integral of 1 over y?
I would usually picture that as like 1y to the power of -1. Could I do that?
That would normally be a good idea, but for the special case of 1 over y, you cannot
Okay.
use the reverse power rule.
Oh, okay.
It's a special case. What happens? 1
Um,
over anything is the natural log of that something. Unless it's powered, you have the
okay.
natural log.
Okay.
Yeah. Then so remember that 1 over x is the integral of 1 over x, sorry,
Mm-hmm.
is natural log of x. Don't make the mistake of using the power rule. In fact, you will notice something's off when you try to use the power rule because you'll have to add 1 to the power, which will make the power 0, and then you'll have to divide by the power, which is 0, which is weird.
Right. Okay.
Impossible, right?
Mm-hmm.
So be careful. Now, on the left side, you end up with natural log of y. On the right side, what happens?
Um, uh, x to the power of 2 over 2 to the power
Exactly.
squared.
And remember that, of course, you integrate it on both sides. So a lot of students be like, why aren't we putting the plus c on both sides? You don't have to. You can just put it on one side. Because the thing is, technically, of course, there is a constant here too. Let's call it C1, let's call it C2. But at the
Mm-hmm.
end of the day, both of these are unknown. So if I subtract C1 on the right side, I will still not know that just as much as I didn't know it before. So we just put one to, just to say that there is a number in there that we do not know about.
Okay.
Okay, so you can just put one C in there. Um, that's essentially it. Now, uh, okay, one more thing. So this is called the general solution. Okay. Now you might think, oh my God, this is going to be another layer of like complexity, but it's very easy to understand why this is called a general solution. C could be anything. This this function, when you plot it, it could be this, it could be this, it could be this, it could be this, it could be anything in between. There's an infinite number of possibilities because a plus C addition will decide how like far up or bottom like down it is basically because it's a vertical translation part, right?
Yeah.
So we need to find C to get a particular solution. How? We need an initial value. So if they tell us then when x is 0, y is 0,
Mm-hmm.
that doesn't work actually. Y is 1, for instance. We can now use this initial value. We call this an initial value. Remember that initial value doesn't necessarily mean that x is 0. Any value, any set of values given is just
Okay.
called the initial value. So by plugging in this initial value into the general solution, so natural log of 1 plus 0 squared over, oh, sorry, equals 0 squared over 2 plus c, and trying to solve for c. Natural log of 1 is 0, 0 squared over 2 is 0 plus c, which means that c is 0. So now that I found c, I can finally write down my particular solution. Why is it called the particular solution? Because it's the solution to this particular problem,
Mm-hmm.
right? The specific case when the initial value is this. So that's
Right.
why we call this. It's basically the same thing with the c given.
Mm-hmm.
Okay.
Okay.
So that's the only thing you need to know. Now, the thing is, I don't know if these questions pop up in the exam, but there are questions. So this is going to be like the exercise 10A is all about these kind of problems where you just have to simply like, just solve the equation using this method. Okay. I'm
Okay.
going to put some of these questions on the board, right there. Try these out for some practice. However, there is a whole other class of questions where you have to essentially make the differential equation yourself and then solve it. Okay,
Right.
so let me show you an example of that quickly, and then let's do the past paper question that we have.
Okay.
So look at this question, for instance. Velocity is defined to be the rate of change of displacement with respect to time. Okay,
Mm-hmm.
remember, okay, so velocity is defined to be equal to the rate of change of displacement with respect to time. What does that mean? The derivative of displacement with respect to time. You
Okay.
take mechanics, right? You know that s is displacement
Yes,
and
I
not
do.
speed, right?
Yes.
So, okay, they've also written it down. So s is used for displacement anyway. So velocity is defined to be the rate of change of displacement with respect to time. The velocity of a particle at time t is inversely proportional to its displacement from an origin. Oh, okay. Okay. Anyways, so using the first statement, we can write down an equation. V equals the derivative of displacement. That's true, isn't it?
Mm-hmm.
Okay. And on top of that, they've also given us another piece of information, which is that the velocity at time t is inversely proportional to its displacement, right? So
Mm-hmm.
velocity is inversely proportional to the displacement, right?
Okay.
That's basically how you write this statement down in math. And you can convert this to an equation by saying v equals some unknown constant of proportionality, we call it, divided by s. Are you familiar with this idea?
I don't think so.
Okay. Basically, if I tell you that, like, I don't know, A is proportional to B, you will say, okay, this is how you say A is proportional to B. And then you
Mm-hmm.
can convert this to an equation by saying A equals KB. K is some constant that I can only find if someone gives me one like set of AB. Okay.
Right.
So
Okay.
if I tell you that, when A is 2, B is 10, then you can tell me what B will be when A is 3, for example. Because you need one data point to understand what kind of proportionality it is, how strongly are they proportional. And K is the guy who decides that. And of course, K will depend on your problem, like, the data given to you. So that is why V being inversely proportional is written down as 1 over S instead of just A is, A with B. If we say inversely proportional, we say V is proportional to 1 over S. This means inverse proportionality.
Okay.
And how do you convert that to an equation? Again, just put a K. Okay, so like just like before, put a K up there.
Mm-hmm.
So this is the equation. Now, if we plug in both of these together, remember that a differential equation can only have two variables. Right now, if you look at this guy carefully, you will notice three variables, v, s, and t. So this is a problem. We need to have only two variables. Otherwise, a differential equation cannot be separated for the variables. You don't have three sides in an equation, right?
Mm-hmm.
So we need to basically use the second piece of information to realize that v is actually k over s. And by plugging in v as k over s, I get this very nice two variable equation.
Right.
Only s and t. Remember, k is not a variable. It's a
Yeah.
it's called a proportionality constant or constant of proportionality. Okay. It
Okay.
pops up whenever someone says two things are proportional or inversely proportional.
Mm-hmm.
Okay. Everything making sense, by the way? I feel like I'm going a bit too
Yeah.
fast.
It does. It does make
Okay.
sense.
Let me know if you need me to slow down. Sorry. So
Okay.
this is the differential equation that we end up with. Again,
Mm-hmm.
two lines gave us enough information to build a differential equation. The first line is that velocity is the rate of change of displacement. Remember, rate of change means derivative. So v is derivative of displacement, of course,
Yes.
with respect to time. Second line tells us that v is inversely proportional to displacement. So v is equal to k over s. Combining them gives us this differential equation. Okay.
Yes. Mm-hmm.
Now, in part, so this is the answer to part A. Part B says initially the displacement is 2 meters. Okay. So
Okay.
when t is 0, displacement is 2 meters. And when t is 1, displacement is given to be 5 meters. I
Right.
don't know why they gave us two data points, but let's see. So here's what we're going to do now. Separation of variables. We see two variables, we see a differential equation. We can convert that to a, separated variable situation. So how
Sure.
do you suggest we start with that?
So we could do ds equals to k over s times dt. Mm, and then we could do ds times s.
Yep.
Yes. Equals, yeah.
Yeah. And then that's it, right? Because
Right.
all the s's are on the left side, all the t's are on the right side. Don't worry about the k. It's a number. It's just that we don't know it yet. Okay?
Mm-hmm.
It's not a
Okay.
variable. So integrate both sides. What is the integral of s?
S s x.
Mm. So you're integrating with respect to s. Imagine that was x being integrated with respect to x. Same thing. Do whatever you would have done to the x.
S squared.
Mm.
Okay. Equals,
S squared.
oh, s squared over 2.
Exactly. And then
Right.
what about the k? Remember, k is a number. Imagine 4, whatever.
So k t.
Exactly.
Okay.
And then plus c. So we have this equation now that relates the displacement of this thing to time directly. Okay.
Right.
So you see, they didn't tell us anything about the displacement and time connection. But now, using just the information given to us, we can find out how far it'll have moved in any amount of time we want. That's the idea of, solving differential equations. Anyways, so now, okay, look at the question carefully. Solve the differential equation, giving your answer in the form of t equals a function of s. Okay. So we
Okay.
need to make t the subject here, remember that. But
Yeah.
for now, let's try to find c first. We know that when t is 0, s is 2, right?
Mm-hmm.
Okay, so let's plug it in. 2 squared over 2 equals k times 0 plus c, which means that we have 4 squared over 2, sorry, 4 over 2, which is 2, equals c. So c is 2, okay? Which means
Okay.
our equation now looks like this. Ah, okay, this is why they gave us 2 data points. So now I'm going to use the second data point to actually find the proportionality constant also. So I can
Okay.
plug in t equals 1 and s equals 5, this one.
Mm-hmm.
So when s is 5, t is 1. So we have 25 over 2 equals k plus 2. If I subtract 2 on both sides, I'm going to have 25 over 2 minus 2 equals k, which is going
Mm-hmm.
to give me 21 over 2 equals k. That is my k value. And now I can finally say that my equation is this, uh, plus 2. But remember, I need to make t the subject, otherwise I'll lose a point.
Okay.
I'm going to multiply everything by 2 first. Trust the process,
Mm-hmm.
because I don't like denominators. So I
Yeah.
multiplied everything by 2. And I'm going to subtract 4 and divide by 21. Boom.
Okay.
Got it?
Nice.
So as you can see, most of it is just algebra, honestly. It's just the separation of variables. I guess you could call it a new method, but that's also algebra. So,
Right.
Okay, so the next question is easy. I'm not gonna do it. Find the time when the displacement is 10 meters. Just plug in S for 10 and find T, right?
Right. Okay. Yeah.
And that's it. So this is the kind of problem, the worst kind of problem you can imagine. I mean, of course, this was very easy compared to the things you will see. But let's look at the problem we have working, in a class paper right now.
Okay.
So part the word um, identity mixed in with the derivation problem. Okay. So
Okay.
since y is secant cube theta, and they're saying that by writing secant cube theta as 1 over the cosine cube theta,
Mm-hmm.
show that the derivative of this guy, of this thing, is going to be 3 sine theta secant to the power 4 theta. Wow. Okay, so we're gonna have to get a bit, by the way, it would have been very easy if we could just directly derive this guy. Because, why? Because if you have secant cube theta, that's essentially the same as this, right?
Mm-hmm.
And to derive this, you just have to first do the outside, right? And then
Right.
multiply by the derivative of the inside. I
Right.
don't know what the derivative of secant is actually now that I think about it. It's tangent? No.
Secant theta tangent theta.
Okay, that makes sense. This would have been very easy to do because now you have 3 secant square theta times another secant theta times tangent theta. Tangent theta just means sine theta over cosine theta, which basically just means sine theta secant theta. Because, sine over cosine is the same as sine secant, because 1 over cosine is secant.
Okay.
So this comes from the tangent. Oops. And this is just secant itself. So we have how many secants? 4 secants
Mm-hmm.
and 1 sine. So this would have been very easy to, I mean, comparatively very easy to do. But did you get this, by the way?
Yeah.
It was
Um,
almost like I was talking to myself, sorry.
it's okay. Kind of. If I don't, then I can watch the video back.
Yeah, yeah. So just as a quick, when you're watching the video, you'll get it. But secant
Right.
theta, the derivative is secant theta tangent theta. This part is just chain rule. So I derive the outside, imagining that the inside is just x, basically.
Mm-hmm.
Okay.
Okay.
And then I multiplied by the derivative of the inside, which is that. Okay. Now, tangent theta is sine over cosine, which is sine times secant, because 1 over cosine is secant. So I converted tangent to sine secant right there, and the secant is still secant down here. Now you have 4 secants here and 1 sine. So 3 secant 4 sine theta. Watch it at like 0.25x, and I think it'll make a bit more sense.
Okay.
Um,
Yeah.
okay. So the reason I'm going fast is because I want to get to the point actually here. So
Right.
now how do we solve this without using those nice, methods of using So we're gonna use quotient rule because it's a fraction. Okay, I mean at least that's what I'm
Mm-hmm.
expecting. So the quotient rule says that if you have u over v and you want to derive it, it's gonna be u prime v minus v prime u over v squared. So if u is 1 and v is cosine cube theta, which I'm going to write as cosine theta cubed just for my kind of visual help, visual
Yeah.
aid. U
Mm-hmm.
prime is going to be 0 and v prime is going to be, what do you think? Chain rule problem right here.
Yeah. So 3 cosine theta 2, to the power of 2 times the times negative sine
Good job.
theta.
Exactly. So we have this, which is basically negative 3 sine theta cosine square theta. Um, Now we can actually plug everything in and we get u prime. Actually, we don't need to write this because u prime is 0, so the whole term is 0.
Mm.
Minus v prime negative 3 sine theta cosine square theta times u, which is 1. And then I need to divide this by the square of v. Oh God, which is going to be the sixth power of cosine theta, because the square of this is going to be the sixth power,
Yeah.
which leaves us with, okay, the negatives cancel out, nice.
Mm-hmm.
3 sine theta cosine square theta over cosine 6 theta. If you
Mm-hmm.
cancel this with the 6, you get 4 powers of cosine at the bottom, don't you?
Yeah.
And that is secant to the power 4,
Right.
because 1 over cosine 4 would be secant 4. Does
Mm-hmm. Okay.
that make sense? So
Yes.
hence proven that if I derive y using the long method of quotient rule, I will get this.
Okay.
Make sense? That's 2 points. That's crazy. Well, I mean, the working isn't that much. But to crack the code that you're supposed to use this method is the
Mm-hmm.
tough part, I think.
Yeah.
So now let's take a look at this. Um, okay. Since you only know one method, I keep saying that because there's 20, there's so many methods, it's crazy. But
Mm-hmm.
since you only know one method, it's going to be really easy to do these questions if you just know what to do, right?
Okay.
Separate your variables. So let's do that.
Mm-hmm.
You tell me, how do I start?
Okay. Um, I could, I don't know, maybe make d theta over dx the subject. Or
Sure, but again, remember how what I said my first step? I always like to remove this dx from here first.
right. Okay, so
Just
x
helps
squared
you. Yeah,
plus 9 sine theta d theta equals x plus 3 cosine 4 theta times dx.
exactly. Now, let's move all the x stuff away from here and let's move all the theta stuff away from here. So
Mm-hmm.
this guy needs to go to the right. This guy needs to go to the left. No, other
Right.
way around. Sorry. Sorry.
Okay.
This
Okay.
guy needs to go there because we need x's here,
Okay.
right? So the theta needs to leave from here. So what do we do?
So x squared plus 9 divided by over x plus 3.
No, no. I mixed it up. Sorry. Look,
Oh,
we have d theta here, right? So we
mm-hmm.
want all the theta stuff on the left side with the d theta. So we should move this guy over there and then move this guy down here.
Right. Okay.
Yeah,
So x squared plus 9 sine theta d theta divided by cosine 4 theta.
and this side.
And then x plus 3 over x squared plus 9.
Now, here's the fun part. Um, you have sine theta. Of course, remember, okay, whenever you have two parts, remember that they're trying to make you see the parallel, okay?
Mm-hmm.
Look at this guy and realize that this is basically what you just proved as the derivative of something.
Right.
I mean, close enough, I guess, right? So just
Mm-hmm.
keep that in mind. You're gonna need that.
Okay.
Oh God, plus 9 dx. Okay, now, um, okay. So the problem is, look, we know one thing. We know one thing from earlier that if you have y equals, what was it? Secant cube theta, deriving this will give you 3 sine theta secant 4 theta, right? We know this.
Mm-hmm.
So now we have sine theta secant 4 theta here, and we want to integrate it. What do you suggest we do?
Um,
Doesn't look like, I mean, almost looks like that. What's missing?
the 3.
So what do you suggest we do? Because if there was a 3 here, I could directly convert this whole integral into secant cube theta. Because I already know that if I integrate this, it'll go back to secant cube.
So I could times everything by 3.
That is one way to do it. I would just multiply by 3 and divide by 3 at the same time. Remember this from earlier?
Yeah.
To make the form show up, we could, just basically reversibly put a constant multiple in there.
Mm-hmm.
But yeah, you could multiply by 3 also.
Okay.
Oh, yeah, you could do this.
Mm-hmm.
So you have 1 over 3 now, and since we already know what derives to become 3 sine theta secant 4 theta, we can just write it down directly. That's the beauty of knowing that derivation and integration are inverses of each other, they're opposites of each other,
Right.
right? So whatever
Mm-hmm.
we did derive to get this will become that again. And now comes this guy.
Mm-hmm.
Um, that does not look fun at all.
Yeah.
Um, what method can we use here is the question. I'm wondering substitution, but I don't know. Something says there's an easier way.
Mm-hmm.
X squared plus 9. Ooh, okay. The reason this question is an 8-pointer is this.
Mm-hmm.
We're
Right.
supposed to use trigonometric integration identities for this.
Okay.
I don't know which ones because I don't remember them.
Mm-hmm.
Let me try to. I think they're in your formula booklet though, aren't they?
Yeah. Um,
Yeah.
what will it be under?
Uh, Trigonometric integration or something like that.
Um,
Inverse trigonometric, maybe even. Let me check.
oh, okay. Integration. So it's x over x squared plus a squared, right?
Yeah. So a squared
Equals,
in this case is 3 squared basically here.
yes.
And
So
again, here we have, sorry,
that equals 1 over a,
1 over
the
3
inverse of tan, um, and then over, or times x over a.
times off. Tangent inverse of x over 3. That's what you meant.
Yes.
Yeah. And then plus, what is this guy? 3 over x plus 3 squared.
Okay, so 1 over 3,
Sine inverse, I think.
um, plus, oh, okay, so there's, okay, yeah. It's the log, or wait, no. I only see 1 over,
1 over, yeah?
yeah. Wait,
You-
does that still work?
1.
Sorry, what? Okay, the microphone is kind of cutting.
Can you hear me now?
Yes.
Is it 1 over 1 plus x squared?
So I see 1 over x squared plus a squared
Yeah,
equals
that's the one.
that was before. And then, isn't it the same?
What?
Okay, I think the microphone is cutting off again. It's still not quite there. In the meantime, while your microphone
Hello?
connects, I'm gonna send you a
Ah,
screenshot. Okay, sorry, I can hear you
yeah.
now. I sent you a screenshot of the formula book.
These are hard to remember. Okay,
Yeah,
so we have, first of all, if you have a 1 over 1 over x plus a squared, basically, that is going to be this, right?
right.
So since we have, so first of all, I don't think we have any of these options because we have x over x squared plus 3 squared, right?
Yeah, that's why, yeah.
Okay, so there's two kinds of situations happening here. A bit of a complicated one. Let me explain. The
Okay.
first one is not a trigonometric one because look, Let's look at each of these individually. X over x squared plus 9 dx. Do you agree that here the derivative of the bottom, what's the derivative of the bottom, by the way?
2x, that's
Just
it.
that, right?
Yeah,
And we have x at the top. If we had the derivative of the bottom at the top, do you remember that
right.
rule that, you can get the natural log directly?
I do remember that there's a
Hmm.
rule.
Yeah. So by putting a 2 here and a 1 over 2 outside, we can
Yes.
now see that the derivative of the bottom is present at the top,
Mm-hmm.
which means that I can directly write down natural log of the bottom.
Right.
That's the rule, okay? So
Okay.
if the derivative of the bottom is present directly at the top, simply do natural log of the bottom and call it a day.
Okay.
Now let's look at the second one. We have integral of 3 over x squared plus 9. Okay,
Mm-hmm.
so the first thing I'll do is realize that this is trigonometric. Whenever you have x squared plus a number and there's no variable at the top, just a number, okay? That's always going
Right.
to be trigonometric. See, all of
Okay.
these three cases are trigonometric situations. So, first things first, which one does it match best with? It's an addition, so arctan, this one,
Right.
right? Okay.
Okay.
Now, what's the problem? We have a 3 at the top. We should have a 1 at the top. So let's take the 3 out.
Right. Okay.
And we have a 9 at the bottom. We're supposed to look at what a square is, so we can say 3
Mhm.
square.
Right.
Okay. Now it looks exactly like this.
Mm-hmm.
So let's convert it to its integrated form. It's going to be 1 over 3. By the way, there's a 3 still outside. Don't forget that. It's going
Right.
to be 1 over 3 arctan of x over 3. And
Mm-hmm.
now we can simplify this by canceling this out here, which leaves us with tangent inverse of x over 3. And that is your derivative for the second part. Okay.
Okay.
So two takeaways, very important. Whenever you see anything of this, why am I writing this again? Whenever you see a sum of an x squared with a number, or a subtraction of an x squared with a number, or a subtraction again of an x squared with a number,
Okay.
immediately, like, take your head to inverse trigonometric integrations. Okay. Hard to spot. Well, not anymore because you know the idea. This is
Mm-hmm.
always going to be the case. Okay. Except when there is not a number at the top. If there's not a number, it's a variable, do not go for this. Okay.
Okay. Got it.
That's two things now. Third thing is this trick is insanely important. Okay.
Mm-hmm.
When you have a sum at the numerator, you can break each numerator component down into a separate fraction. This is not
Yes.
partial fractions, by the way, that's a different thing. This is just
Mm-hmm.
like you using basic fraction rules. X plus
Mm-hmm.
2 over 2 means the same thing as x over 2 plus 2 over 2. You can
Yeah.
distribute the division. Okay.
Yeah. I got it.
This is very important, like extremely important. I would say that every 8-point plus question will have this method popping up because this
Mm.
breaks down one integration into multiple ones, right, for each numerator component. And number
Right.
two, you need to always remember from this point onwards, whenever you see a sum or a subtraction of x squared with a number at the bottom, it's going to be inverse trigonometric unless there is not a number at the top. If there's a number at the top and it's a sum, inverse trigonometric all the time.
Right.
If there's a variable at the top, go for something along these lines. Okay? Forcing the derivative of the bottom to appear at the top. There's a bunch of notes to make here, as you can imagine. So when you're watching the video, make sure that you kind of skim through everything I've said, make separate notes of everything, because
Okay.
integration. The last question you can always expect it to be differential equations, by the way.
Okay.
Anyways, so we found out that, we've completed the integration essentially. So let's put everything together. So the left side is equal to 1 over 3 secant cube theta, and the right side is now equal to half natural log of x squared plus 9 plus arctan of x over 3. And then, of course, don't forget the plus c unless you only want 7 points out of this question.
Mm-hmm.
Now, since it's 8 points, I can imagine that it's an initial value problem, meaning they will give you an initial value. Okay.
Okay.
X equals 3 when theta is 1 over 3 pi. So let's plug everything in. 1 over 3 secant cube, what was it?
One
1
over
over
two.
3 pi
Mm-hmm.
equals 1 over 2 natural log of 3 squared plus 9 plus arctan of 3 squared over 3 plus c. And that means that c is going to be 1 over 3 secant cube pi over 3 minus half natural log of 18
Mm-hmm.
plus arctan of 3. This is your c. Okay.
Okay.
Now, remember, the question is not over. They said solve the differential equation and find out what cosine theta will be when x is 0. Okay? Weird
Okay.
question to ask. But all they're saying is plug in x equals 0 and make cosine theta the subject. Okay?
Okay.
So let's do that. I'm gonna plug in x equals 0 into this equation.
Mm-hmm.
So we're gonna have 1 over 2 natural log of 9 plus tangent inverse of 0, which is 0 by the way,
Mm-hmm.
plus c, so all of that. Oh god, that's not what I wanted to do. There. So
Okay.
let's not do the
Mm-hmm.
this. Now remember that secant cube is just, 1 over cosine cubed, okay? And other than that, multiply both sides by 3, right? And
Okay.
then just flip both sides and then cube root both sides, and that's your answer.
Mm-hmm.
So don't do it like I did, by the way. Calculate
Yeah.
this and then put it in. By the way,
Yes.
it might just be better to not calculate it. I don't know. Wait.
Mm-hmm.
Okay, it says yeah, then you can calculate it. You get the question, right? I think everything beyond this point was super easy,
Yes.
right? This stuff, like these few lines of work, are like worth 20 points in an exam, I would say. Like there's so much possibilities of questions coming, especially out of these things that I've done here. Okay. Breaking
Right.
this fraction down into two separate ones, using this method, where you try to make the derivative of the bottom appear at the top. This stuff, like you can expect this to show up in two or more questions even. Okay.
Right.
Insanely important. And that's about it. I can expect that you'll have a lot of questions, and I can expect that you won't have them right now.
Mm-hmm.
So just watch the video later and let me know, if anything still confuses you. We
Okay.
can work on
Will
that then.
do.